so I will turn off Raylib build. I will make sure that I'm on my, oh no, that's not the one I want. I want to be down here, ANSI view. So again, if you look at the view here, you can sort of think about what the model might look like. My playing board is just 7 squares. And each square can either be empty, could have a toad in it, or could have a frog in it. And that's it. So like the entire model is effectively just a length 7 array. And if we look inside of said model, we will see that I have a board size constant, which is literally the size of what I just said. There's 7 pieces to this board. I put this in as a constant so that like things like the view could query in to know the board size. Even though it's sort of fixed in this game, you could probably make variants of the game that have board sizes greater than 7. I have an enumerator behind the scenes. Instead of calling them frogs and toads, I called them L and R's because one of them starts on the left and one of them starts on the right. And so the ones that start on the left are called L, and the ones that start on the right are called R, and E is going to be empty. So I have this nice little enumeration so that when I create my board, it's going to be an array of cells. And then I made 2 fixed arrays of cells of board size. And this maybe could be done in a better way, but I just made them like static and const expr, and one is the starting state of the board, and one is the goal state of the board, and they're just reversed versions of each other. So this one has all the L's on the left and all the R's on the right, and an E in the middle, and vice versa. The final goal state has all the R's on the left and all the L's on the right. And there's not much more to the model. In terms of its state, it has a Boolean of whether or not the game has been solved. It has the board itself, which starts off with the starting board. And then it's got some helpers that can test to see if an index is valid. They can, given a cell type, figure out which direction that cell should move. The L's move to the right and the R's move to the left, which, saying it out loud, is a little confusing. They maybe should just be called frogs and toads. And then we have these little instance helpers where I can check to see if a numbered cell is empty, and I can potentially change the state of the Boolean is game solved by running this evaluate board function. This is all in the header file, and all of that exists inside of a frog toad namespace. And I only added a namespace because I literally ran into a namespace collision. I have a struct here called model, and Raylib also has a class called model. And so that forced me towards best practices, which is I should be putting these things in a namespace. I mean, I also could have just given that thing a more specific name, but the better way to do it is just to put it in a namespace. And then if we look at the implementation details for the model, it doesn't need a constructor because the state is very simple, and it starts with the is game solved being false, and it starts with the board array already having a fixed set of cells in it by way of the starting board. So I didn't need a constructor at all. It is a struct, so there'll be, the stuff at the top is public by default. This is all public, so the board size is public, the class enum is public, and then this is the public API. Reset just sets the board back to the starting board, sets the game solve back to false. That's what's going to be happening when you hit the letter R in some of my controllers. we have like a getter for is the game solved. It's marked const because it's not going to change anything in the object. Cell at is going to return what's at a particular position, and it's going to be using the enum. It's also const. It'll check for validity, and if the index is valid, it'll return what's at that board's position. If the index isn't valid, I just return empty. This is a little helper function that just turns the enums into text. And so if you pass it a cell, it'll return either, if it's empty, it'll return a period. If it's an L, it'll return a T for toad and an F for frog. Again, the naming is a little bit awkward when I say it out loud because that sort of looks like true and false. I used a nested ternary operator. Yay or nay?
Yay.
Sometimes.
It seems okay, right? Like if the cell is empty, use a period. Otherwise, another ternary.
I think that's about as deep as you should probably go.
I think
Not
so.
go
I would
any
say,
further.
Kyle, this is one of the places where you should definitely have a comment.
Yes, that is absolutely true. That this is like,
At the least.
yeah.
Like just so that, so at least
like converts cell enums to text. E goes to L goes to E, F goes to, or yeah, R goes to. There you go, Cole. I've got a comment in there now. It's a little bit more clear.
You could, the only thing I'd say at this point, do they have the triple line, what is it?
Like the really, really, really equals?
No, they're just the fancy, nice comments where you're, like, I guess it's like Java style.
Yeah.
If you do the 3 and you get like a summary so it autofills, because this won't tell you about it if you hover over the.
That is true. Yeah. I'll go back and do that later.
I was gonna say this might be the perfect place to do like a switch case with like single line cases.
Yeah, that's also you could easily do a switch here as well. I'll leave it for now because I was sort of happy with my nested ternary, but I don't know.
Whenever you make them, you feel so cool, but then it's like no one else is like gonna know what to do.
In one of my portfolio projects for getting into this program, I had like a triple nested ternary.
I might have docked marks for that on your portfolio. No,
That's how you know that it's not ChatGPT code.
that's probably true.
It probably wouldn't do that.
It was never
It would probably do a more like probably a
It would just be a
switch case or something.
Well, I had switch cases in the project too. It is one spot where I was like checking a bunch of Boolean stuff, and I was like, I could do this in ternary
I have some
because I just
crazy
learned about ternary.
There you go.
Yeah, no, it was the same type of thing. It was a uni project that I was doing before I ever got formal instruction for like programming too. So it was like super like awful practice. And there's one line where I had like it's a like I think like well there was a there's like 2 terners and then there's like each one of them they'll have one inside. And it was to determine if something was above, below, to the left or right. It was crazy. And like I remember looking back at it and I like it was like
Yeah.
can't
What
even
not to do?
Yeah, it was terrible. It was terrible. But it was kind of funny. It was like one of those like there's probably a million ways of doing it better, but maybe I can find it. We can like have a code showcase of the worst code we've done.
Have a good laugh.
Yeah.
So again here, there's not much more to the model, but again, like just notice that it just encapsulates the game and the game logic so that nothing else outside of the model needs to know or care or even can interact with anything to do with the game or the game logic. The view should be completely dumb The view is simply going to look at, it's going to use the get cells. I think there's like a way of getting the cells. Oh no, I think I just get the board directly. Oh no, we got get cells here. So the view is just going to like get the cells one by one and display them. I'm using like static const expers for certain things because those are all things that like they do not rely on the state of the model instance at all. And so if we looked at those, they're just little evaluators. And then there's little helpers that the outside world can use to test to see if, or no, this is private state. Is a cell empty and is the game solved? The game is solved when the board equals the goal board. And that's it, that's the entire model. If we look back at the
worst VR usage, but it's pretty bad. It's up there.
I have a interfaces header file. And here's something that I haven't shown you before, which is, this is how you make like abstract classes or classes where this will eventually build us up towards getting to polymorphism. If you mark a function, whether it's a constructor, a destructor, or a method as virtual in C++, that marks it so that like when a object that inherits from that thing gets called, it will always execute the most derived version of the thing. So it'll call like at sort of the lowest layer of the inheritance chain. And if you mark things like, if you mark everything virtual in your function and you just, or in your class or struct, and you assign either default or 0 to those things, it makes it abstract, meaning there's like you're not providing any implementations for these things, so you could not create an instance of this iView. You also could not create an instance of this iController, because you've got these like functions that have no implementations. You need to derive from those to actually instantiate them.
So I have a question. Yes, you can overwrite. Is there a difference between default and 0? Because I was trying to look it up and I found some like information that indicated there might be a difference, but I couldn't figure out what the actual difference was.
Default, you're actually getting like it's going to generate like a method for you.
Oh.
And so like for example, like the default.
Doesn't do that?
Exactly. 0 says is marking as like no implementation, whereas default gives it like the default implementation. For a destructor, I'm not sure what that is. For a constructor, it's like a 0-arg constructor, so it'll allow you to construct the object with 0 arguments.
Yeah, that's kind of what I like worked out, quote unquote, experimentally, and based on what information I was able to find, but I wasn't 100% sure like what it was actually doing.
Yeah, so default, like, and the only reason I've marked this destructor as like a default and virtual is if you don't do that, like I don't need to do that for this particular program, but it's just best practice to do that. Otherwise, if you inherited from this controller and you created your own destructor, it would not get called. Because it would always, because the destructor is not virtual, it would always call the parent's destructor. It only calls down to inherited versions of things if they've been marked virtual, which is it's just like a quirk of C++. And so, that's why that's there. It's literally not necessary for my code, but it's just best practice to always have a virtualized destructor in case someone down the inheritance chain is ever going to create their own destructor. So this gives me my interface for a view. A view is simply going to be a class that inherits from iView that provides an implementation to this draw function that takes in a reference to the model. And notice that the view gets a const reference to the model because we do not want the view to even by accident be able to mutate the model in any way, right? And also you would do this in practice if you're working for at a company where there's a large team, sometimes it can be very tempting when time is of the essence and maybe you're a newer developer to like have the view quickly just mutate the model in some way, right? And so here, right at the interface level, I'm saying that like, no, you're not allowed as a view to ever change the model in any way. You get a reference to it, but it's a const reference. And so all views are just gonna have to implement that one method. Views can have more methods than that if they want, but at a minimum to be considered a view, they're going to have to implement that one method. The controller similarly has like a step method, meaning like this is the user getting like, it's going to be like the next step in the process. Again, I'm not totally happy with the name of that function. It maybe should just be called get user input, because that's what it's doing. And it takes in a reference to the model, but it needs to be able to mutate the model, because it's going to call out to the model to, for example, add the next move to the model. So it needs to get a reference to the model, but it can't be a const reference. And then I made this little tiny static helper function. Static means it's scoped to the struct. I made everything structs because I just didn't give them constructors, and so they could also be classes. But I made this little helper function that all controllers could use, and what it does is when given a particular character and a reference to a model, it'll either, if the character is an R or a capital R, it'll call reset on the model, and otherwise it'll try to make a move. And here there's probably some commenting that needs to be happening here. We're doing some like ASCII math. That's why I'm doing key -1, because it's the character coming through. And so if it was like the character for the number 6, to get to the actual numeric value 6, you have to subtract the ASCII value of 1 from it. And so that's not necessarily that clear. And so when you are going to be implementing your raylib implementations for these functions, you're going to have to create a view that inherits from my interface. Again, interface here isn't necessarily the correct word. There are no interfaces in C++, but it sort of is acting like an interface in this way of like, it could also just be called an abstract class. Which is like a class that doesn't have any implementation details, like where you can't actually instantiate these things. But yeah, you would need to create something that inherits from iController, and you would need to then create the override for this step function, and you would need to create something that inherits from the iView, and you would need to implement and override the draw function. And then we can see how that actually plays out in my console controller, for example. Here's my console controllers in the header file. I'm including the interfaces header file so that I can get access to these two interfaces, or abstract classes, if you will. And then I'm saying I'm going to create my own console controller that inherits from, that's this little colon here, the iController, and I'm going to override the step method. And we use the override keyword here just to indicate that this is an override. That's just a nicety for the compiler. You're letting the compiler know that you're overriding something, and if you've typoed the name of the thing that you're overriding, it'll give you an error. It'll say like, oh, there's nothing called that to override, right? So there's a classic error that used to occur in C, where you would like, uh, call this thing like steep by accident, and then you would wonder why it wasn't working. Here, if you put override in there, the compiler will make sure that there is something to override in the base class. Yeah.
Do these like abstract classes require you to implement the things in them? Because that's how they work in C#, is you have to implement stuff, otherwise there's an error.
You
Class
will
is
get a
not
compile
valid
error
if you don't override.
You'll get a compiler error when you try to instantiate from your thing that doesn't override it, because it'll still have no implementation, right? So it'll still, like, I could make another abstract class based off an abstract class, and that would be fine. But if I try to instantiate that second abstract class, that's when the error will be thrown, because I've tried to instantiate an abstract class. So you're not forced to override them. You can create like a hierarchy of abstract classes.
Does default throw an error when it's called, or is that the difference between it and zero? Like zero is no implementation for like function.
And default you can call default.
You can call default nothing else.
Yeah.
Then would that not throw an error if it's not overridden?
If I tried to, like, if I went, let's just say, like, if I called this steep and I went to my implementation details here of the same console controller and I called it steep, I should get an error when I try to instantiate the console controller here. Object of abstract class type is not allowed.
Okay, so it's the same as C#.
Yeah.
You need to override.
But you only get the error at this level. Like if I didn't try to use a controller in any way, it would compile.
Yeah.
So I can have abstract classes that inherit from other abstract classes, but I just can't instantiate them without it throwing an error.
It's confusing trying to change the words because in C#, abstract means this has no implementation, it has to be overridden. Virtual means this has an implementation and you can override it.
Oh, interesting. Yeah, so in C++, virtual just is that keyword that says, like, make sure if there is a chain of inheritance to call the most derived version of this thing,
Yeah.
which is weird.
But that's, yeah, so it's different to C#.
Yeah, yeah. And in fact, it's like they're using the same keywords, but they mean very different things.
Yes, and that has been confusing. I also just learned, because I did a quick Google search, that like classes can inherit from structs, and it's just like changing my worldview. It's
Well,
weird.
yeah, because classes and structs are
I know they're
not
just the same thing, but like they shouldn't be. Like why?
Yeah, they're literally the only difference is the privacy controls.
It's just so weird to have a class as a child of a struct.
It is a bit weird because then it's like,
What are we doing?
well, then also like, what is the default privacy? Like, are you? I guess you're inheriting the things you inherit from the struct are going to be default private, and the things that you, like the properties of your class, will then be default public. Probably not recommended.
Also, there is protected, right?
There is.
Okay.
Yeah,
I guess that
absolutely.
makes sense,
Yeah, and that those work the same as C#.
Yeah.
Yeah,
Where it's private but not to child.
exactly. Yeah,
Well, that's just silly terminology.
it is. It's a bit awkward. And then you can see here, like the console controller is very, very simple. It's the thing in the program here that is being called with the model once a tick in this case, or once a loop. Same thing here. But if we look at its implementation details, here I'm just using getch to get a single character, and then I am calling apply command, and that was just the thing that existed inside of the interface. That was this little static method inside of the interface that takes in a character and either calls reset on the model or tries the move. And I'm not even 100% sure that this is something that should exist in the interface. I was trying to like preserve a little bit of like repetition, because I would sort of like almost all controllers for this game I'm going to recommend when you do the Raylib implementation that you just do keyboard input to keep things simple. You could do mouse input, but then things get a little bit more complicated because the controller will need to know some stuff about the view at that point, because it'll need to know, like, are you hovered over, like which things you're hovered over. And so there's ways of exposing that from the view back to the controller, but we can keep things a little bit simpler by just doing keyboard input and not needing to know anything about the view in the controller. Which is why I thought the supply command would be something that I could sort of like provide to all controllers, as long as all controllers are using keyboard input. Yeah, so that's the controller, and then the only thing left is the view. Again, the view is an abstract class. We're going to create our own version. There's going to be two versions that you can see how I've implemented the view. One's the simple console view, and one's the slightly more complex ANSI view. But the console view simply inherits from the view and marks draw as being something it wants to override. And then if we look at the implementation of that, not much to it. It's going to go and have a little for loop from 0 to, and it's going to go out to the model because it has access to the model. It'll ask for the board size. So it'll go to 0 to the board size, and it will just request the character at, and that's that function where I had my double ternary. It's going to take the cell at that position and get back a character for that. And there's an argument that maybe that should happen at the view level. Right now it's happening at the model level. Again, that's if we look at the model, it's the model here who's currently responsible for converting cell enums into their textual representation.
Yeah.
Right?
I get what you're saying, where that kind of feels like.
Right? There's an argument that it doesn't deserve to live there in the model.
It's almost like a two-string override, where it's like a way of converting
Yeah.
your data into something readable.
Yeah, but it wouldn't be hard to move this to the view either,
Yeah.
because the view has access to the model's class enum, because that's public on the model. The view has the model, so the view could do that conversion. So moving it from the model to the view, yeah, there's definitely an argument to be made that that doesn't deserve to live here. The other thing that is a little bit awkward here is I've hard-coded the number 7 in here. That should probably be the board size. So that we don't have any dependence on the board size in case that ever changes. Because like the whole big idea behind both OO and MVC is that you're just trying to reduce the number of changes that you need to make anytime you go in to make a change in the code, right? You should really, if you're going to make a change in the code, you should only have to change it in one place. If you go into the code to make a change and suddenly you're having to change code everywhere, that is usually a sign that your code is poorly architected, and a lot of programmers will call that shotgun surgery, because you usually do not want to do surgery with a shotgun, although, you know, it might sort of work in some instances. But yeah, there's like shotgun surgery is you go in to make one change and suddenly like you have to make sort of a bunch of changes everywhere in your code as a result of that. So again, the model just implements this, it'll now work, and same thing goes for the ANSI view. The ANSI view's header file, it also goes and overrides draw, but the ANSI view's a little bit more complicated. It's going to have a constructor and a destructor, and so I have signatures for those. It also has a bunch of static methods for ANSI things, like the ANSI reset, what I'm calling bold and dim here, red, blue, and green. Bold is just white, dim is a slightly gray. And so again, the views, the implementations of the views can look fairly different, right? The console view was very simple. It just simply implemented the override, whereas the ANSI view is more complicated. It also implements the override, but you can have other stuff in it. So for your raylib views, you're gonna have a bunch of other stuff in there that is gonna be raylib dependent. And then inside of that ANSI view, the constructor does some initial stuff. And this is where I used ChatGPT, because I just didn't know how to do all of this ANSI stuff. So all the little ANSI codes I just asked for. How to clear and hide the cursor, how to reset the screen and show the cursor. Yes, I could have looked those up, but it generated the code for me. And I'm not sure I even really need to be flushing the output there. And then on draw here, it's just slightly more complicated. This is the overloaded draw, moving the cursor to the top left, writing out some text, and then I've got these little helpers that I made, and they are going to be sort of strung in at the places where I want to bold things, I want to dim things, I want to loop over my board, and before I output the piece, I want to set the color of the piece according to the cell. Here, I am keeping everything in the view, so rather than asking the model to do anything, I'm directly comparing the current cell, and this is getting, I don't know if I like this either, because look at, like, when I want to compare to the current cell, I have to go to my namespace, and then I got to go to the model, and then I got to go to the enum, and I got to check if it's the left or right enum.
That's so many scopes.
I know, so like, I don't know if that's the best way of handling things either. But I need to know what I'm about to output, because I want to output one in red and I want to output the other in blue. And so, I don't know, that felt a little bit dirty or weird to me. But I didn't.
The cell is just an enum, right?
The cell's just an enum.
I think it should exist in the namespace, not the struct. Like it would just remove.
That would at
the
least
model.
remove the model
I don't
from
think
it.
should belong to the model.
Yeah, that's a good
Enums
argument.
exist on a namespace level always.
Yeah, I like that. I like that a lot. Because then, yeah, that could, and all that means is just moving this out to here.
Yeah.
And so I won't do that just now because it'll force my code to change in a bunch of different ways, but I'll do that before I assign this as an assignment. Because yeah, I think then that would also make the craziness that I'm sort of dealing with over in the ANSI view here of like all of this chaining.
I've never had an enum like belong to
To
in
a
any
thing?
other code bases. It's always just belong to a namespace. Like
Yeah.
system dot.
Like at first when I just wrote the model, it felt like it belonged to the model. But then like once I started coding up the views and seeing things like this, I was just like, oh, yeah.
It's kind of like if the mod or if the enum's only ever going to be used within like internal functions, then I think it's probably a good idea to have it belong
Yes.
and be like a private enum.
But then like because it's public and because it's being used, yeah, outside, it really doesn't deserve to be part of that model.
Is your view not also inside the namespace, by the way?
What's that?
Is your ANSI view not also inside the frog code namespace?
It is.
Okay, you shouldn't need the namespace.
So if it was outside, if yeah, if there's namespace scope, you would just do cell R.
Oh yeah, okay, let's see.
Yeah, so you could just get rid of that probably because it's in the same namespace.
That's true. I'm inside of the frog toad namespace.
So it would be very small if it was.
And so if it was just in the namespace proper, then yeah, then it would be lovely. Because then it would just be cell R
Yeah.
all on its own. Okay, I'll fix that up as well before. Oops, don't control Z, Kyle. Make sure that still runs without any issues. Yay. Okay, good catch. That's lovely. And then yeah, it's doing its thing, but then now this view is considerably more complex in its implementation than the other one. But again, from the outside world, all we see is view.draw passing in the model. So as long as you've implemented the interface correctly, which is you've implemented that draw function, you're good. And then then yeah, what's going to be up to you is going to be implementing the Raylib controller, which I've stubbed out for you. And by stubbed out for you, I just mean that I've created the Raylib controller header file. I have put it in the frog namespace, frog and toad namespace, and I have already set up the Raylib controller to inherit from the interface and set it up to say that it's going to override the step function. Same thing goes for the Raylib view. I've set that up. I added a little bit to the Raylib view because the Raylib view, I wanted the Raylib view to be responsible for its own height and width, but then like that height and width needs to get out to the outside world because we need to call Raylib's initialize window function to provide it with a height and the width. And so I gave the Raylib view getters for the window height and the window width. And that seemed like a reasonable addition. So those exist on the Raylib view as well as the override on draw. And then I did stub out the implementations of both of those as well. So there's like the Raylib controller. Oh, I gave you the answer. Can't see that. I didn't yet remove it. Nonetheless, it's not that long, right? It's going to just be a bunch of key tests. And then, oh, do I have the implementation here? No, I removed the implementation here. But notice here, I'm just like currently just hard coding the return values of the window height and the window width. This might not be what you want to do. You might want to calculate the window height and the window width based on the size of the elements that are within it. Or like you might have your own way that you wish to calculate window height and window width, but you just have to return something here. Whether it's a calculated something or a hard-coded something is going to be up to how you implement things. Same thing goes for what's going to go inside of this draw function. And you can, just like my ANSI view had more than just the draw function. It had like a constructor and a destructor, and it had a bunch of little helper classes. Your Raylib view could also have a bunch of helper classes or extra state or whatever you might need to do what you want to do with Raylib, but as long as the only thing that really matters at the end of the day is that you've provided an implementation of draw that is going to query out to the model and draw the representation of the model to the screen. And I don't think I need that anymore in there either. Yeah, there's a lot there, but hopefully my code is well structured. I don't think that there should be any huge issues you will run into, and you'll be able to reference like the existing console controller and console view, the existing ANSI view, and sort of the stubs that I've put in place for the Raylib stuff. And so it'll just be about doing some simple draw calls for the Raylib view and some like isKeyPressed calls for the Raylib controller. But I think it'll be a nice little view into the model view controller design pattern, which I think is just a really lovely design pattern. And as I said, it is now part of, I haven't had a chance to play with it in Unreal Widget MVVM is what it's called.
What's wrong?
Model view model. The model view model pattern. That is not an Unreal invention. That is just something that that's like an extension of model view controller that actually does come from the architectural pattern world, where you have a model, a view, and this thing in the middle, which isn't a controller, but it is the binding thing.
What if we had like a view model? And a view model?
So, what is it?
The view
It's not a
model?
controller.
So that's the thing is I haven't looked into it. It says here the view model is a value converter, meaning it is responsible for exposing and converting the data objects from the model in such a way that they can be easily managed and presented.
So it's an interface?
No, this is nonsense. We don't need it. Sorry.
I think the view model is there for like if you have stuff in your model that is like stored in like a non-human representable way, like it's stored in binary, it's stored in some kind of weird data structure, you can then like convert it to the human representation in the view model. And like, so like, you know, cause you often like, before you put things out into a GUI, you like convert it to a string.
I would just do it in the view, me personally.
Yes, but it's supposed to be like one more layer of abstraction so that like if you were to do something like, I've seen people talk about this for like internationalization, right? You would do your internationalization here so that your internationalization isn't like hard-coded into the view.
Okay, that's fair enough, I suppose.
Yeah, so there's a reason for it. So
Sometimes it might be too much.
I mean, that's the thing with OO, right? There's like, you can sometimes go too far with OO patterns. Any final comments or questions on my code, model view controller? I haven't written the assignment yet. I'm gonna write it tomorrow. Does it sound like a fun assignment?
I think so. I will have to probably change the project structure to be able to do it myself.
Yeah, I mean, that is true. The project structure right now is very, very basic. It's just like everything is in one folder. It's just like a bag of C++ headers.
I would suggest like encouraging you towards C-line at the very least, because it looked like Visual Studio was kind of struggling with some stuff and being a little funky.
We are going to move to, well, not C-line, but Rider, or what is it called?
That's Unreal, what you're talking about.
Yeah, for Unreal.
Yeah, that's right.
Yeah, Rider, which is just a C-line variant.
Yeah.
Oh.
I know like
That's
some success
What's
with
the,
C-line.
like, I mean, they're all like a very
They're all JetBrains.
default JetBrains editor, yeah.
Have a virtual one of like
Yeah.
you know, processor recording.
Yes. Absolutely. I'm basically done for the day, I think. This is...
Bye.